and let's get started. So again, what we're doing is we're looking for specific slope value, a specific x value for a slope. So here's my pen. Okay. You can title this Finding, what do I call it? Hold on. We're finding Nemo. Yes, we're finding Nemo. No, we're finding a specific, finding points with specific tangent slopes. That's it. Finding points with specific tangent slopes. Finding points. Basically what we're doing is solving for a specific derivative. You like the second one better, Manuel? Wasn't that Nemo 2, Finding Dory? Electric Boogaloo? Anyway. Solving for a specific derivative is what we're doing. For a specific derivative. So recall, if you will, the derivative is the tangent slope equation of a function, right? It tells us where, or what I should say, it tells us what the tangent slope is at any given x value. The derivative is the tangent slope equation. So if you have, oh goodness, if you have a graph, I don't know what I'm doing here. Draw the line, there we are. If you have a graph, right, all of these tangent slopes at different x values, right, this tangent slope here, this tangent slope here, this tangent slope here, right, all these different tangent slopes at these different x values, right, all, the derivative, I should say, the derivative is equal to the tangent slopes at certain x values. Right, that's what we have found so far. And the formula we have, the derivative formula, our derivative, is equal to f of x plus h minus f of x, oops, I should say limit over h, the limit as h approaches 0. Is how we found our derivative formula, right? We have a derivative, we find a derivative, we find a specific slope of different kinds of equations. Right? The derivative is the tangent slopes, at specific x values. You plug in the x, you get the tangent slope at that spot, right? And we've done this before, that's what we've done, and we've seen the kind of like pattern of how to solve this equation, right? We've seen this kind of pattern where we have like polynomial equations you solve a certain way, square root problems you solve with the conjugates, fraction problems you solve with finding common denominators, right? We have this kind of pattern we have for solving these things. There are other patterns we'll get to later on, but those are the basic ones are familiar patterns. So we know how to find the equation. We know how to find this derivative by using this formula, finding the derivative. what we're going to want to do is, in this case, we're not looking for the slope. I'm going to tell you the slope, and I want you to tell me where the x is. So now, what we're going to do is we are going to find the x value that has a specific tangent slope. That's our goal this time. Before, we found a slope of a certain point. I would tell you what the point was, I would tell you where we're looking for the point, and then you would find the slope. This time, we're going to tell you the slope. We know what the slope is. We want to know where on this equation that tangent slope exists. Where on this function does it have this particular tangent slope? You're going to find the x value that has a specific tangent slope. That's our goal this time. Okay? But first, a little bit of, what do you call it? A little bit of, not terminology, like symbology, I guess. First, we're going to rearrange our symbols. Let's talk symbols. I don't want to keep writing the word derivative. Derivative. I don't want to keep writing this word. Right? I don't want to keep writing the word. Right? We shortened it a little bit. We said instead of the equation of the tangent slopes, right? We shortened it from equation of the tangent slopes to the word derivative. But I don't want to keep writing this word derivative. It would be nice if there was a way we could indicate that we have a derivative of a function. And some of you may have seen this, but when we say derivative, what we're looking for is f, and you put a little hash mark there, of x. This is prime. We call that prime. That little symbol there, f with the little hash mark, whoopsies. That little mark means f prime of x. So this is f prime of x, which is the symbol for the derivative. F prime of x is how we indicate that we have found the derivative of some function f. F prime of x is what we say for the derivative. So when we are looking for our function, really what we have is f prime of x equals f of x plus h minus f of x over h. Oops, limit as h approaches 0. This is really what the symbology, right? F prime of x, this is the derivative function. F prime is equal to this thing. Because that f prime of x is the derivative equation. Okay? Just a little symbology here to make our lives easier so we don't always have to write derivative formula or function or whatever. We have this f prime now. We can talk about derivatives using this symbology of f prime. Okay? Cool with that? F prime. So let's talk about derivatives. Let's say, for example, I want to find the point on the function f of x is x squared, where the derivative is equal to 1. So this is our task. I want to find the point on, not of, on, find the point on f of x, which is x squared, this equation. Find the point on this graph, on this function, where the derivative is equal to 1. When I say this, where the derivative is equal to 1, I would say, like another way to write this is saying f prime of x equals 1. That's what we're looking for. I want to find the point on f of x, where it's equal to x squared, where the derivative is equal to 1, where f prime is 1. Right? Look at how much better that is. Instead of all of this, I can say this symbology here. Right? I can shorten it. Instead of saying where the derivative is equal to 1, I would say where f prime equals 1. This is telling me the derivative is 1. So this value right here of 1, this value right here is the slope. That 1 value, this 1 right here, the slope, I should say, of the tangent line, of the tangent. That 1, that value of 1 that we're looking for, that number represents a slope. That number represents a slope, and I know that this number is a slope because it is attached to a derivative. Its f prime is this value. F prime only tells me slopes. But the derivative is a slope value. So we're looking for the point on this function where the tangent slope is equal to 1, where the derivative is equal to 1. And so you can imagine a picture of this. You can imagine a picture of this. It's always good, picture. It's always good with picture. With AP Calc, it's always good to like imagine a picture. So can we imagine what the equation x squared looks like? Yeah, we have that function. It's a parabola, right? Like that, touching at 0, right? And I want to find the point on x squared where the derivative is equal to 1. Well, a slope of 1 is, like a slope of 1 is a line that's like this, right? Slope of 1. It's a positive slope, right? It's angled kind of like not too much, not too little. It's like a 1, up, rise 1, up 1 over 1, rise over 1, right? So it's going to be, like, first of all, is it going to be somewhere over here or somewhere over here? Are we going to be negative or are we going to be positive for our point? Just looking at we know the slope is this direction, right? Yeah, just thinking about it, we know it's going to be in this area over here somewhere. Not going to be over here, right? Because the slope is positive, it's going to be somewhere here. I mean, like somewhere over here. We don't know exactly where. We don't know exactly what the x is, but that's what we're looking for. We're looking for what x value, which could be a positive x value, where the slope is somewhere over there. Not over here. We know it's going to be over on this side of the equation. Okay? So what we need to do to find this x point value is, the first thing we need to do is take the derivative. Our first step, step 1, find f prime of x. I need to know the slope formula. I need to know the derivative equation. What is the derivative? What is the derivative of this f of x function? And I do that by saying, well, f prime, I know, f prime, we have this equation, limit as h approaches 0 of f of x plus h minus f of x over h. So I find my derivative using the formula. Right? So my f, do this in like green, f of x is this f here, my function. This is the equation that we're doing the derivative of. We're doing the derivative of this function. So we need to use this equation in our function, in our limit, in our derivative equation, in our f equation, this x squared. So we're going to say it's the first part, x plus h squared, right? Because I'm plugging in the x plus h, right? I have x plus h into my x here. X plus h squared. And that's the first part. Minus regular function, just x squared over h. If this is looking a little familiar, if the pattern here, right, if you see, you feel like you've done this before, you probably have, right? X plus h squared, right? We did the x plus h squared means there's two of them, x plus h times x plus h. Distribute that whole situation, you're going to get x squared plus 2xh plus h squared minus x squared over h. Seeing you've done that before, right? So we're finding our derivative, same as before. Plug in our x plus h minus the original equation, do some simplifying, some algebra stuff, and I see, again, that some stuff cancels. My x squared cancels with negative x squared, so I'm going to get limit as h approaches 0 of 2xh plus h squared over h. And then what is it that I do now? What's the trick I have here? 2xh plus h squared over h. We want to cancel this and factor out an h, right? You see our h's here, factor out a GCF. So we're going to get the limit, let me do this, limit as h approaches 0 of h times 2x plus h over h, and my h is going to cancel, and so I have, you see, all this detail stuff, I'm going to have the limit as h approaches 0 of 2x plus h, and this h is going to become a 0, so I just have 2x. So f prime of x is 2x. That's my formula, that's my equation of my derivative. Okay? F prime is 2x. I found this formula, I found this equation, found the derivative, using our formula, doing some simplifying, all that stuff. Okay? So we have an equation now that describes the derivative. Now the question is, right, what do I do next? Well, what we're looking for is, we want to find the point. This means I want an x value. I want the x value. We're looking for the x, we're looking for this. We're looking for this x value, right? Where the slope, where the derivative is equal to 1, where the slope of the tangent line is a 1. Well, I have this equation that describes the derivative. This is f prime is 2x. So how do I get from, I know the formula for the slope equation. I know what I want. I want the x value. how do I get what's like, I don't have an idea what the next step would be to find the x value where the derivative is equal to 1. Where the derivative is equal to 1. Here's my equation of the derivative. What can I do to this equation, or what do I do to find x value where the derivative is equal to 1? Here's my derivative equation. What can we do? Plug in. Okay, maybe we plug in. Plug in what? Plug in what? Where? We want the derivative to equal 1. We want the slope of the tangent line to be 1. We have our derivative equation here. I want to find the x value. What are we plugging in? What can we do? Here's our derivative equation. Right, a derivative equation. I want to find the x value where the slope of the derivative of the slope of the tangent line is equal to 1. Anyone see anything connecting this to this up here? Any similarities? What are we noticing? Look at this. Here's my derivative equation. Right? Here's my derivative equation. What do I want this derivative equation to equal? Yeah, look. I want my derivative. What do I want my derivative equal to? It says I want the derivative equal to 1. Here's my derivative, right? Here's my derivative equation. I want the derivative equal to 1. So I'm going to make this 2x equation that I found, I'm going to make this equal to 1. I want it to equal 1. So I'm going to say, right, I'm going to do this with this. I'm going to say 1 equals 2x. And I'm going to solve for x. You could say plug in. You could say make, or set, I should say here, here's what I'm going to do. Set the derivative. Set the derivative. Set the derivative equal to the slope. Equal to the slope. Set the derivative equation, I should say, set the derivative equation, f prime of x equal to the slope that we want, and then solve for x. So that's how we figure out where the x value is, where the slope, the derivative, is equal to 1. Right? So there you go. Solve that, divide both sides by 2, and I get that x is equal to 1/2. This is the, I should do this in blue. This is the point. This is the location where f prime of x equals 1. This is the point. You could say location, I'm going to say point, fine, point. This is the point. It's the x value point, the x coordinate, where the slope of the tangent line is 1. And I knew that because I set the derivative equal to 1, and then I solved for x. I got x is 1/2. Okay? Does that Make sense? Is that clear? Like, see how that works out, right? You have something you want you have a slope that you want the derivative equal to. You have a slope that you want the derivative equal to. You find the derivative equation, and then you set that equation equal to the slope, and you have the point. That tells you what location in the graph, what x location in the graph, your tangent slope is going to be equal to that particular slope. You're solving, right? You're solving where in the graph, what x value of the graph has the tangent slope of this particular amount of 1. So this x value right here, this x value here is going to be 1/2. Okay? X value is going to be 1/2. So you found the x coordinate by locating the derivative equation, solving for the derivative equation. Take that derivative equation, set it equal to the slope that you want, set it equal to the slope, and then solve for x. Okay. Here's the next question. Okay, we have the x value, right? What's the y value? I have 1/2 comma what? This is the x value. What's the y value? How do we find the y value? How do we find the y value? Plug it in, Adrian? Yes. Plug it into what? Plug it into what? Well, I've got a lot of equations here. I've got this f prime equation. Do I plug it into here? F of x. Thank you. Yes, I plug it into f of x. I'm looking for y. I know the x value. I'm looking for the y value of my original function. Yes, f of x. I plug it into this equation here to figure out, right? Because that's telling me, this f of x is telling me the graph. And I want to find the point on the graph. So I plug it into f of x. Plug into f of x. Yes, 1,000 points. I'm sure that makes up for something. plus 1,000 points for Adrian. All right, so we're going to say f of 1/2 is 1/2 squared, which is 1/4. So my y value is 1/4. Messiness. So the coordinate point is 1/2 x and 1/4 for the y. All zoomed out. Well. Okay. Plug into the f of x equation. You get your y value. So this then is our final answer, our coordinate point, 1/2 comma 1/4. That's the location of the location on the graph where the tangent slope is 1. No easy way to say that. Let's try this again. Por ejemplo, find the point on f of x equals, let's say, let's find a complicated one, square root of x, where f prime of x equals, let's say, 3/2. Okay. Find the point on f of x where f prime of x is 3/2. So, same situation first. First, we find a derivative. Find f prime of x. So we know that f prime of x is equal to the limit as h approaches 0 of f of x plus h. I'm just gonna plug it in. I know this formula at this point. We're just gonna plug it in. Our first block is take this f square root of x plus h minus second half square root of x over h. Oh, look at that straight line. Beautiful, everyone. $1,000 points for me for drawing such a great straight line. All right, so we have this limit function. How do we do this? It's got a square root, everybody. Have to multiply by the conjugate. Square root x plus h plus square root x. Square root x plus h plus square root x. And we're going to get our conjugate situation. The limit as h approaches 0 of, this is going to be, remember, I only need to do for conjugates, I only need to do the first and the last. I don't need to worry about my middle pieces, they're going to go away. So I'm going to get x plus h minus x over h times square root x plus h plus square root x. Right, when I multiply the square roots together, the square root goes away. I'm just left with the inside part, right? If I do this piece here times this piece here, they're the same, x plus h, right? And square root times square root's going to go away, leave me with just the inside pieces, just the inside parts. Same thing with x, root x times root x, square root of x times square root of x is just going to become an x. And then down below, I keep it separate, I don't multiply, I keep them apart. Up on top, nice thing, the x's cancel. So I'm going to have limit as h approaches 0 of h over h times square root x h plus square root x, right? H's cancel. Again, I'm showing you all these details. If you can see what's happening, if you can see where this is going, you don't need to be so explicit, but it is very useful to have all these details here because, again, on an AP test, if they ask you to do this on a free response section, they'll want you to have all these particularities. 1 over square root x plus h plus square root x, which is 1 over 2 root x, right? Because this h goes away, becomes 0. Square root x plus square root x is 1 over 2 root x. And so this is f prime. That's the derivative. There's my derivative equation. Okay. So now, next step, set f prime equal to the slope you want and solve for x. Take our f prime equation, make it equal to the slope we want. Our slope we want is 3/2. So I make this 1 over 2 root x, 1 over 2 root x equal to 3/2. And I solve. Okay. Solve this. So let's see. What am I going to have to do? I'm going to have to get my x on the top of the situation, do some division. I'm going to, well, I could cross multiply. 2 fractions, right, everyone? I can cross multiply. That's allowed. Maybe I cross multiply, or maybe I just multiply both sides by 2 and then by root x. Again, a lot of ways to figure this out. Cross multiply. recall your algebra skills for how to solve this situation. So I'm going to have 2 root x times 3 is going to be 6 root x equal to 2 times 1 is 2, right? 2 times 2. I'm going to divide by 6 on both sides. Divide by 6 on both sides. So I'm going to get the square root of x is equal to 1/3. And then to cancel my square root, I square both sides. Square both sides. So I have my point x equals 1/9. There's my x value. The x location of my point. X value of the point. So I know my point is 1/9, comma something. Right, again, I take this 1/9 to find the y value. I plug it into the f equation. I know to find the y value, I plug it in, right? F of 1/9, that's the square root of 1/9, which is 1/3. So that's my y value. X and y. One-ninth, comma 1/3. That coordinate point is the location on the square root graph. Remember, square root graphs look like this. The x value of 1/9, y value of 1/3. At that point, that's going to have a slope of 3/2. Interesting, right? Interesting. Questions, concerns, worries? Mr. Mitchell, what is that squiggle? Mr. Mitchell, why did you write that value? What does that mean? I can't read what it says right there. Okay. It's called learning, Manuel. It's called learning. Mind blown. All right, I'm going to give you one to try right now. I want you to try one right now on your own, and then we'll see what the answer is. I'm going to give you a few minutes. I would like you to do the following question. Well, we'll see. Right now, oh goodness, right now I would like you to try this. We'll see how long this takes you. Find the point on f of x equals, I'm going to give you an equation, let's see, 2x squared plus 1, where f prime equals -2. All right, everybody? There's your situation. Find the point on that equation where f prime equals 2. Find the derivative formula, find the derivative equation, set that derivative equation equal to -2. Find the point, find the xy point where the derivative is -2. Take like 5 minutes.